my name is Koonce. I'm from Louisiana, and my project is titled The Effect of Sodium Chloride on Hybrid Taxodium Selections. My project focuses on solving the global problem of erosion caused by saltwater intrusion. Around the world, we are losing countless miles of land every hour because saltwater is replacing freshwater. When this happens, sodic soils are created that kill freshwater plants that typically thrive on coastlines. When these plants die, their roots die with them and are no longer able to hold in soil, so the soil is free to erode away with the brackish water. A genetic engineering lab dedicated itself to creating a cross between the Montezuma cypress, which can live in sodic but not submerged conditions, with the bald cypress, which can live in submerged but not sodic conditions, to make a tree that could live in both submerged sodic conditions. I became one of the first people in America to actually own these trees, and the first recorded to test them in a lab. This was done in a three-aimed research project. The first aim was to determine the species of tree with the least amount of salt in their foliage after a year. I stripped each of the 40 trees of their leaves after 1 month of the trees being established and ground them up, dehydrated them, and then sent them through a refractometer to test for their element concentration, looking specifically at sodium to test how well the trees were at excluding salt from their system. I did this again after 1 year and then recorded the results in the same way. The second aim was to determine the growth of each species. I measured the trees directly after their initial planting and then again after a year later and recorded growth of the trees individually. The third aim was to determine the electrolyte leakage of the roots when exposed to 3 different concentrations of salt. I took 12 samples of the 2 most successful hybrids and a control species and then exposed them to 0,000 parts per million salt, 10,000 parts per million salt, and 20,000 parts per million salt for 48 hours on a circular orbiter. I then rinsed the roots and exposed them to distilled water, this time on the circular orbiter, for 48 hours. I then recorded the electrolyte leakage using a TDS meter after the roots were removed from the different concentrations of water. Results from Aim 1 showed that all hybrids were significantly more successful at excluding salt from their foliage than the control species. Results from Aim 2 showed that almost all hybrids experienced significant growth, while the control group, unsurprisingly, was not able to live in saline conditions and either decreased in height or had no significant change in height in most cases. Finally, the results from Aim 3 show that all hybrid roots leak significantly more slow than the control species when exposed to 3 different concentrations of salt. What does this mean? All 3 tests show that the hybrids are not only capable of surviving, but they are capable of thriving in areas affected by saltwater intrusion. Because of this research, we are able to determine that should the trees be planted in areas affected by an erosion caused by saltwater intrusion, they would be able to root in soil and successfully prevent horrible damage caused by erosion.